People Scientist, the podcast dedicated to helping us optimize our health with the latest scientific findings on nutrition, health, and medicine. I, your host, Dr. Stephanie Caligiuri, will be here with you every single week, bringing us information to ignite our thinking to help us be one step closer to the healthiest we can be. Hello, my People Scientist Army, and welcome back for another episode on the People Scientist Podcast, where every week I arm you with some scientific evidence so that we can all lead the healthy life that we want to live. Right now, I'm recording on a beautiful, sunshiny Saturday. It's about 30 degrees Celsius or about 86 Fahrenheit in New York City right now. So what am I doing staying inside recording this podcast? Well, I made a commitment to all of you to bring good quality scientific evidence every week, and I'm so happy to do that. But when I'm done recording and uploading this episode, you can bet that I'll be running outside, renting a bike, and going through Central Park. I cannot wait. What do you all have planned for this weekend or week? I'm always curious actually what my listeners are doing when they listen to my episodes. Like, for example, I always listen to podcasts while I'm at work running experiments. So feel free to message me on social media to let me know. So let's get started on this podcast episode so I can go run outside and be in the sunshine, eh? So get ready today for another listener request episode. My very good friend Billy requested that I cover the scientific evidence on alkaline ionized water, which is also called hydrogen-enriched water. Now, this water is becoming very popular, particularly in Japan, and is being studied by many Japanese scientists for its potential antioxidant effects. But what does the scientific evidence say about hydrogen as an antioxidant? Let's find out. Let's start off with a few core takeaways. Hydrogen lately has been sold to the public through hydrogen-enriched water, or through machines that make hydrogen-enriched water. And this type of water goes by many names, including alkaline ionized water, electrochemically ionized water, or reduced water. Now, reactive oxygen species are present in our body and are generally considered bad because they can induce DNA damage, inflammation, aging, and increase the risk of cancer and heart disease. Now, some scientists claim that hydrogen is the ultimate antioxidant because hydrogen very readily binds to specifically the worst type of reactive oxygen species, the hydroxyl radical. When hydrogen interacts with this oxygen radical, it produces water and a hydrogen ion. As a result, hydrogen-enriched water has been studied a lot in cell culture experiments and animal models of disease in which inflammation and oxidative stress are implicated. With hydrogen-enriched water studies, as we commonly see, it appears very promising when it comes to cell culture and animal studies. But then when it is taken to the clinic, it appears to be less effective than predicted. I still think hydrogen as an antioxidant is still a very intriguing concept. It just requires more clinical investigation. So if you're still interested, then let's jump into those details. Back in 1975, hyperbaric hydrogen chambers were tested for their ability to reduce cancer progression in mice and did seem to have a benefit. But hyperbaric hydrogen chambers were not continued to be investigated as hydrogen gas can be explosive and dangerous. So scientists looked for a safer means to deliver hydrogen, and they discovered and started producing hydrogen-enriched water, which in particular is very popular in Japan right now. Hydrogen-enriched water is alkaline ionized water, which can occur naturally in some springs around the world, but lately hydrogen-enriched water is being produced by passing mineralized water through a cathode, or having water come into contact with magnesium sticks. In this scenario, the water molecule H2O will combine with magnesium to produce magnesium hydroxide and hydrogen atoms, for example, therefore producing hydrogen-enriched water. Some companies are selling machines for home use that can do this, or they're selling the magnesium sticks as well. When the water becomes ionized in this scenario, it now has more active atomic hydrogen, low dissolved oxygen, a higher pH, so now it is an alkaline water, and negative redox values. Now, the biggest claim to ionized alkaline water is that it has great antioxidant potential. Hydrogen atoms, in theory, would be excellent guards against reactive oxygen species, as hydrogen very readily binds to reactive oxygen species to form water and hydrogen ions. So let me briefly explain first reactive oxygen species. These types of molecules contain oxygen and have high activity and like to react with DNA, fats, and proteins in our body. Typically, their effects are bad. For example, they form the lipid peroxides I spoke about several podcast episodes ago that increase the risk of clogged arteries and heart disease. Now, if reactive oxygen species react with DNA, they cause DNA mutations and can lead to cancer cell growth. But reactive oxygen species are also important for the normal functioning of our immune system. So they are not always bad, but they can be bad in high amounts. Reactive oxygen species are generated through normal metabolism, but also from things such as cigarette smoking and pollution. So if we have too many of these reactive oxygen species, it can lead to what is popularly called oxidative stress, which leads to inflammation and chronic disease. So that is why antioxidants are commonly researched, which would sequester and stop the activity of reactive oxygen species. And hydrogen is thought to be very good at this. Now, in an in vitro study conducted by Srihatta in 1997, they showed that just like the common antioxidant vitamin C, ionized hydrogen-rich water was able to scavenge reactive oxygen species and prevent oxidative damage and DNA mutations in vitro. So, is hydrogen better than vitamin C for its antioxidant potential? It doesn't appear to be, according to this study. However, some would argue that hydrogen is a better antioxidant than others, as it appears to specifically sequester the damaging reactive oxygen species and avoid the ones that are important to our immune system and health. For example, atomic hydrogen appears to react with highly reactive oxidants such as the hydroxyl radical and peroxynitrite inside of cells. It doesn't significantly disturb metabolic redox reactions and doesn't affect signaling reactive oxygen species such as nitric oxide. Others also speculate that hydrogen is a superior antioxidant because hydrogen rapidly diffuses into cells and makes it more bioavailable in our body. This is important as Hong in 2010 pointed out that we don't want to completely eliminate all reactive oxygen species, as the elimination of all of these types through powerful antioxidant therapies could have negative health effects. Because, for example, our immune system uses reactive oxygen species to fight off bacteria and viruses, and reactive oxygen species are even a mechanism that our body uses to kill cancer cells. Hong stated that an ideal antioxidant is expected to mitigate excess oxidative stress, but not disturb redox homeostasis. In other words, an ideal molecule should not reduce signaling molecules such as hydrogen peroxide, but should effectively reduce strong oxidants such as the hydroxyl radical. And since hydrogen reduces the hydroxyl radical but does not interfere with other like singlet oxygen or hydrogen peroxide or nitric oxide, that is speculated then that hydrogen is the ultimate antioxidant. But the fact that hydrogen therapy does not sequester hydrogen peroxide in the body is debated as a good or bad thing, as Lisanti in 2011 wrote a review detailing how hydrogen peroxide in our body, when in excess, can lead to inflammation, aging, and cancer onset. But it gets complicated because yes, sometimes hydrogen peroxide is bad, but it also is one of the mechanisms by which our body can kill off cancer cells. So as with, I think, the case for a lot of scenarios, we just don't want these molecules in excess. So let's take a look at some of the cell culture and animal data now for the effects of hydrogen-enriched or ionized alkaline water. Because of its apparent antioxidant potential, ionized or hydrogen-rich water has been investigated for its potential to reduce chronic disease in which oxidative stress may be linked. Now, a lot of chronic diseases do have an oxidative stress component. For example, diabetes, heart disease, cancer, and arthritis are included in that. Now, in 2012, Lee showed that ionized alkaline water could slow the onset of chemically induced diabetes in mice. And Kim in 2007 showed that alkaline water could lower blood glucose levels in a mouse model of diabetes. In cell culture, ionized alkaline water was able to prevent oxidation of low-dense lipoprotein or LDL cholesterol, which is a risk factor for heart disease. Preventing oxidized LDL is thought to reduce atherosclerotic plaques or clogged arteries, but this result was limited to a cell culture experiment. Ionized alkaline water, or hydrogen-enriched water, is also being studied for its ability to reduce damage from ischemia reperfusion injury. Now, ischemia reperfusion injury occurs when there is a lack of blood flow to an organ, then blood flow is regained. This, for example, happens during a heart attack or stroke. For example, if someone is experiencing a heart attack where blood flow to the heart is reduced, and they go to the ER, and an interventional cardiologist will increase the blood flow to the heart again by putting a stent in the heart or coronary artery. The quick regain of blood flow is called reperfusion, and this can actually lead to a lot of oxidative damage to the heart and brain and can contribute to cell death and reduced function of the organ. This oxidative reperfusion injury is associated with heart failure, for example. So in several animal studies, hydrogen gas or hydrogen-enriched saline was provided at times of this ischemia reperfusion injury and was able to reduce oxidative damage, tissue damage, reduce infarct size or the magnitude of the heart attack or stroke. But this was limited in animal studies. So in these animal studies, it does appear to be very promising. What this could mean for the future of clinical care, though, well, for example, when an interventional cardiologist places in a stent in the arteries of the heart for a patient with clogged arteries, perhaps adding hydrogen-rich saline to their IV line could be a benefit. Or providing an IV line with hydrogen-enriched saline for patients that just experienced a stroke. It could be very beneficial in reducing that oxidative reperfusion injury or ischemia reperfusion injury. But this has yet to be investigated. But I think it could be very promising to be added on to standard of care for those patients that exhibited a heart attack or stroke. Now, I would be remiss if I didn't mention the large amount of animal and cell culture data that is currently looking at hydrogen sulfide as a potent antioxidant in ischemia reperfusion injury, such as in heart attack and stroke, which is also proving to be very interesting. Now, is the reason that hydrogen sulfide is effective in animal models of disease because hydrogen sulfide dissociates to produce hydrogen and sulfide? And is it because of the hydrogen? Perhaps it could be in part, but the topic of hydrogen sulfide may be for another episode. But that could contribute to the evidence that hydrogen could be a potential antioxidant. Now, how about the clinical data looking at hydrogen therapy? Huang in 2003 published in the journal Kidney International the benefits of hydrogen-enriched water in patients with kidney failure undergoing dialysis. Often patients undergoing dialysis have a lot of oxidative stress and reduced antioxidant capabilities. Adding hydrogen-enriched water to their hemodialysis solution did indeed reduce markers of inflammation, including C-reactive protein and interleukin-6, but there was no beneficial effect noted on their cholesterol levels in their blood. And unfortunately, there was no follow-up to see if this hydrogen-enriched solution benefited the patients long-term. Nikeo in 2010 conducted an open-label pilot study in individuals with symptoms of metabolic syndrome, such as obesity, diabetes, high blood pressure, and high triglycerides. But there are some major limitations to studies like this because there was no control group, and all the participants knew they were drinking the hydrogen-enriched water, so the placebo effect could certainly confound the results here. But nevertheless, let's see the results of the pilot study. Nikeo investigated consuming 1.5 liters of hydrogen-rich water in 10 women and 10 men. They generated the hydrogen-rich water by placing a magnesium stick in bottled water. So magnesium would interact with water to produce magnesium hydroxide and hydrogen. The resulting pH was slightly alkaline. Some significant improvements in antioxidant status were noted, such as a decrease in T-bars and an increase in the activity of our natural antioxidant system superoxide dismutase. However, they also saw a slight increase in 8-isoprostane, which is an indication of increased lipid oxidation, which is not a good thing, although this increase was not statistically significant. There were no improvements in cholesterol profile or fasting blood glucose. So unfortunately, some of the positive results seen in animal studies were not replicated here in a clinical setting with humans, but they did note some improvements in their antioxidant status. Ito in 2011 conducted again an open-label pilot study with no control group to investigate hydrogen-enriched water in 5 patients with progressive muscular dystrophy, in 4 patients living with polymyositis or dermatomyositis, and 5 patients with mitochondrial myopathies. These participants on average were also pre-diabetic. The participants were asked to drink 1 liter of hydrogen-enriched water every day for 12 weeks. The scientists tested a multitude of parameters in the blood, such as 8-isoprostane, an indication of oxidative stress. They looked at their cholesterol, blood sugar, that gold standard of blood sugar, HbA1c. They also looked at the red blood cells, white blood cells, blood urea, nitrogen, etc. What you typically see, for example, in a blood test at your physical annual follow-up at your family doctor's office. Now, after 12 weeks of drinking the hydrogen-rich water, unfortunately, there was no improvement of any of the blood tests. And there was no improvement in their clinical symptoms, but there also was no worsening either. But they did note a slight improvement in fasting blood glucose for the 5 patients with muscular dystrophy, and an improvement in triglycerides only for the 4 individuals with polymyositis. Ido then followed up this study with a better controlled study that was controlled and double-blinded, and asked the patients with the same above conditions as before to consume half a liter of hydrogen-enriched water every day for 4 weeks. But unfortunately, again, no improvements were noted. Kajiyama in 2008 investigated the effect of hydrogen-enriched water in 30 patients with type 2 diabetes or in those with impaired glucose tolerance. This trial was well designed because it was a randomized, double-blinded, placebo-controlled study. The scientists asked the participants to consume 900 milliliters of hydrogen-rich water every day for 8 weeks. After 8 weeks, there was no improvement in the patient's blood cholesterol levels, blood glucose, insulin, oral glucose tolerance tests, or that gold standard of blood sugar, HbA1c. Although the scientists did note a small decrease specifically in the small, dense LDL cholesterol and a decrease in the electromagnetic LDL cholesterol, which are particular subfractions of our bad cholesterol that seem to be particularly worse because they increase the risk of heart disease because they are seen as more likely to produce clogged arteries as they are particularly cytotoxic and inflammatory. So that was a beneficial effect there. But the hydrogen-enriched water induced no improvement to blood pressure or inflammation, except that they did note a slight decrease in urinary isoprostanes, which is a marker of oxidative stress. So overall from this clinical trial, the hydrogen-rich water did not improve many parameters for patients with diabetes, but it did seem to reduce the particularly bad subfractions of bad cholesterol and reduced one marker of oxidative stress, but had no effect on the other measures of antioxidant status, inflammation, or oxidative stress. So did hydrogen-enriched water have a benefit on this patient population? Well, maybe in particular to the small, dense, or electromagnetic LDL, but otherwise it didn't seem to improve much in this patient population. So now when we take all of the data together, I have to say in the end, it doesn't appear to be very clear. I mean, the cell culture and animal studies had some very promising results in that the hydrogen-enriched water may be able to reduce blood glucose levels, could slow the progression of diabetes, it could have antioxidant potential lowering inflammation, and it could reduce ischemia reperfusion injury. But then when hydrogen-enriched water was studied in humans in a clinical population, it wasn't always very clear. Sometimes it improved antioxidant status and reduced oxidative stress, and sometimes it didn't. It never seemed to improve blood sugar levels or reduce the progression of diabetes. It didn't seem to improve clinical symptoms in patients with inflammation. For the most part, it did not seem to improve cholesterol profiles, although that one study did show that it reduced a particularly bad subfraction of LDL cholesterol. So I think it's still rather confusing and we need far more clinical data. But unfortunately, that's the reality of a lot of medical research, is that we can have some very promising findings coming from cell culture and animal studies. And then when that therapy is investigated in humans in a clinical setting, a lot of the times it fails. And I think it's important for us to remember that this is an example of how something that may be seen in animal studies is not necessarily replicated in humans. And in the end, mice and rodents are not the same thing as humans. And perhaps as a result, we need to push to have more clinical studies and fewer animal studies for that particular reason. But I think a lot of research is now being focused on hydrogen sulfide as a potential therapy, because hydrogen sulfide is also a potential donor of hydrogen molecules in the body. So I think I will do an episode specifically just on hydrogen sulfide as a therapy in the clinical setting as well. So you can look forward to that. But lastly, is it safe to consume hydrogen-enriched water? Well, in the clinical studies, a few side effects were noted as possibly related to the water, such as diarrhea, headache, and heartburn. Sato in 2010 conducted a safety study in cell culture and in rats for hydrogen-rich ionized water that had a neutral pH. The authors noted that up to 20 milliliters per kilogram of body weight in the rats, that there were no observable side effects or concern at this dose. So that equates to about 1.2 liters of hydrogen-enriched water per day for a 60 kilogram individual, for example. But we certainly do need more safety studies in humans to verify its safety long-term. So there you have it, my people scientist army, the scientific evidence on hydrogen as an antioxidant in hydrogen-enriched water. In brief summary, I think it is a very intriguing concept that hydrogen could be the ideal antioxidant. It does appear to be very promising in animal studies of ischemia reperfusion injury, such as in heart attack and stroke. And I do hope that this gets taken to the clinic setting, but it hasn't yet. The few clinical trials conducted are not ideally designed and can only serve as pilot studies. In hemodialysis, hydrogen-enriched solutions in the dialysate appears to improve antioxidant status for the patients, and it did as well in some patients with metabolic syndrome. But hydrogen-enriched water did not appear to have any benefit in those living with inflammatory conditions. It did not benefit cholesterol or blood sugar levels for them as well. I still think that hydrogen as an antioxidant should be investigated further. If there are more clinical trials coming out on hydrogen-enriched water, I will try to update all of you. I think another important point brought to light from this episode is that it is possible to have too much antioxidants in your system. And sequestering some important reactive oxygen species that regulate our immune system and kill cancer cells, it would not be ideal. This would be important particularly for those taking a bunch of antioxidant supplements, and know that there can always be too much of something, even that we think is good. Also, the concept of alkaline water alone without the addition of hydrogen is something that I will cover in the very near future as well. This, for example, includes lithium water and water with alkaline minerals and any effect that these may have on our health and mood. So that is a wrap on this week's episode of the People Scientist podcast. Let me know what you think of today's episode by messaging me on LinkedIn, Facebook, Twitter, or Instagram. This week I will have a very cute photo of one of our People Scientist Army mascot, Luna. What did you all think of our People Scientist Army mascot, Roxy's photo last week? My brother and I could not stop laughing at that photo of Roxy with the free weights and the towel around her neck. We thought it was hilarious. She is so cute. So feel free to follow me on social media for some photos like that and for some extra tidbits of information. Also, feel free to leave me a rating and review or if you are listening on Apple Podcasts, and let me know whether you are liking this podcast or not. Because if you don't like it, then that's also important for me to know. Next week, we will have another listener request podcast episode, so make sure to tune in for that one. I hope you all have a super healthy week. I'm going to go head out in that sunshine right now, so I hope you have a great week, and bye for now. I am a scientist simply sharing scientific evidence. Some of the clinical interventions I discuss are not appropriate for everyone. Before making any changes to your diet or lifestyle, please do consult the advice of your physician or dietitian. My opinions expressed here do not necessarily reflect those of Mount Sinai Hospital and its affiliates.